Hi, good morning. So this is presentation 2, and I am going to present about urban heat islands in the Philippine context. We love our cities. Cities are attractive and cities are inviting. Cities provide a lot of job opportunities, better healthcare services, options for social and financial centers, lifestyle, and even for education. So because of this, people tend to move and live in cities. Only 2% of our land is being occupied by cities, but almost 54% of us are currently living in them. It is expected to rise up to 60% of our population by year 2030. So meaning if we have more people, the demand for space is larger and it will further trigger urban expansion. So this is a characterization of urbanization or the population shift from rural to urban areas. And it results to the expansion of urban areas, may it be horizontal or vertical expansion. So urbanization poses many environmental impacts, and one of them is the urban heat island or urban heat islands. So UHI referred to the higher temperature recorded in built-up urban areas as compared to those surrounding rural landscape. So in this image, we can see that the temperature is relatively higher within your city canyons compared to your adjacent and surrounding suburban residential and rural areas. So according to global studies, the annual mean air temperature difference between your urban and non-urban areas can rise up to 3 degrees Celsius during the daytime and up to 12 degrees Celsius during the nighttime. So why the urban heat island effect occur? We have here a sample rural area and a city area. So in your city, the heat absorption is greater or higher because we have surfaces like cement, asphalt, and some built-up areas. So their surface albedo is low, so your heat is being absorbed rather than being reflected. Also with less plants, the city will have less plant transpiration. And third, with more impervious surfaces, you will have less water penetration efficiency or capacity. So combination of these factors will lead to the heat island effect. So UHI occur globally. Many scientists are already studying the formation of UHIs in their cities, on the region, or even through global scale studies. So it is important to note that the UHI intensity may differ between cities because of geographical and socioeconomic variations. So today we're going to focus on the UHI in the country. So when we talk about UHIs in the Philippines, the first area that may come to our mind is none other than Metro Manila. Obviously because it is the capital region and it is a highly dense urban areas housing a bulk of our population. So because of these factors, many of the earlier researches conducted on UHI was focusing only in Metro Manila. So examples are these researches. So according to Nivares, there is a difference of 1 degree to 2 degrees Celsius between Metro Manila temperature and Bulacan. According to Pereira, the built-up cover has a contribution factor of 1.25, and according to Tiangco, the highest UHI intensity is 2.96 in Metro Manila, and they identified hotspot within the central part of Manila. So in studying UHIs, it is important to know that there are two categories based on the temperature inputs. The first one is SUHI, and the second one is AUHI. AUHI. So for SUHI, the main focus is the land surface temperature difference. So in this example, the SUHI map of Metro Manila for 2017, the red areas are the warmer areas while the blue areas are the cooler areas. And we can see on the right the surface UHI intensity equivalent of these pixels. For the second one, atmospheric urban heat island, if here the focus is land surface. For the AUHII, the main data is air temperature data and its difference between the urban and the non-urban area. So in this example by Oliveros et al., this map shows the maximum temperature of Manila for 11 years as shown in this plot. And in this part, we can see the equivalent maximum temperature of other non-urban areas such as Infanta, Lucena, and Dingalan, Aurora for 11 years. So you can observe the big difference in the values. So according to the study, the difference is up to 2.3 degrees Celsius for the Tmax. And this data are secondary data, as you can observe. However, for GUHeat, we did our own projects, studies, or initiatives. So the first thing is that in GUHeat, we further extend the analysis of UHI to more cities, not only to Metro Manila. So we have selected 7 sites: Quezon City, Baguio City, Iloilo, Cebu, Mandaue, Davao, and Zamboanga. So aside from these 7 sites, we know that there are more and other urbanized cities in the country. So for this one, we are going to generate nationwide scale maps for us also to consider the other urbanized cities. This is an example SUI map. In this case, the LST mapping or the land surface temperature mapping. So for these maps, we made use of thermal remote sensing data such as Landsat and MODIS. So those are free satellite data. And also we develop our own Google Earth Engine and QGIS plugin toolbox for us to automate and process this input data. So what you can see here are spatio-temporal maps showing the distribution of land surface temperature in each city from 1995 to 2020. So these maps are significant for us to understand the formation of UHI in the 7 sites. And as mentioned earlier, we also generate nationwide maps. So in this case, land surface temperature map from 1995 to year 2020 of the whole Philippines. For 2015, this slide shows the top 15 cities or municipalities or Manila districts with highest annual average LST. So we can see here the top 5. Among the top 5, 4 are located within the National Capital Region or Metro Manila. We have Sampaloc, Marikina, Quiapo, and Paco. So only Abra is located outside. So you can read here the other warmer municipalities or cities. So out of the 15 cities or municipalities, 9 are located within the National Capital Region, 3 are located in Pangasinan, 2 in Abra, and 1 in Tarlac. So you can observe how most of the sites or warmer sites are located within cities, especially in the metro. So here is an example, a basic example of a UHI analysis wherein we compare the land surface temperature of Manila and Bulacan. So the UHI and the non-UHI. So here are the maps for NCR and the maps for Bulacan from 1990 to 2020. So here is the graph. The red one is the land surface temperature of Metro Manila. The orange one is the land surface temperature of Bulacan. As you can see, the trend is the same, but the level or range is higher for Metro Manila. And the data, according to the result, there is a difference of 2.6 degree to 5.4 degree. So the difference is really high. So for other non-UHI in Metro Manila or other UHIs, we can observe smaller difference. For example, we have here Baguio City as the urban area versus Sablan, an adjacent municipality, so the rural area. So here are the maps for the subland, and here are the maps for Baguio City. So the difference is 1.4 degree up to 2.7 degree. So relatively lower than that of Bulacan versus Metro Manila. But still, it is high enough to consider Baguio City as a true UHI area. Also in Project GUHeat, we do site-specific studies because we know that for each site, we have unique features that may contribute to the distribution of land surface temperature or air temperature. So for example, in Baguio City, we analyzed the effect of urban expansion to LST, wherein we measured that the increase in temperature per year is 0.11 degrees Celsius. Also in this map, we can see the distribution of hotspot from 1980 to 2020, and most of the hotspots are located within the central business district kung nasaan si Session Road, si Bornam Park, yung mga tourist destination natin sa Baguio. In Cebu City, we analyzed the impact of vegetation, urbanization, and solar radiation. Also, the increase in LST per year is 0.61 degrees Celsius during the cool dry season. Also, as shown in the map, we can see here the extent, the expansion of the UHI extent temporally. So from 1989 to 2016. So obviously the UHI area is increasing. In Mandaue, we analyzed the spatial and temporal pattern of land surface temperature, wherein highly dense built-up barangays, like those located here, have higher average land surface temperature than those vegetated barangays located on the northern and eastern portion of Mandaue City. In Iloilo City, we analyzed the urban cooling island effect of water spaces, wherein urban cooling effect reduces as the distance from water extent increases. So, for example, you have the Iloilo River Esplanade here on the zero axis. So the temperature of the surfaces near the water is relatively lower compared to those areas far from the water source. So the cooling effect was successfully observed from this area to a certain area, or what we call the edge of the influence scale. So after this edge, the effect is already reduced, and the pattern of LST is more dependent on the urban features rather than the effect of the water. So the effect was felt at a certain distance only. In Davao City, we analyzed the urban effects on land surface temperature, wherein we found out that all of these factors, such as particulate matter 10, enhanced vegetation index, NDVI, albedo, elevation, and population density, are all good predictors of land surface temperature. So a map showing the cold here and the hotspot in Davao City. In Zamboanga City, we want to know the relationship between LST and monthly water consumption. So especially the LST and per capita water consumption showed moderate positive correlation. So in this map, we can see here the March 2016 land surface temperature map and water consumption map. So those areas near your city center are areas with relatively higher land surface temperature, or the red color areas. And at the same time, those areas near the city town or city center have bigger consumption or larger consumption of water, as seen here. So those areas with smaller circles have low water consumption, and those areas with bigger circles have higher or larger water consumption. So they have positive correlation even though it is moderate. For Quezon City, we analyzed GIS-based mapping. We did GIS-based mapping of local climate zones. Local climate zones are classified zones based on properties of surface structure such as building height, density of trees, surface cover, etc. So we have 17 local climate zones, and Shown here are 4 examples of local climate zones. Uh, Local climate zone 1 is the compact high-rise represented by Eastwood as the example. We have compact mid-rise represented here by Ugong Norte. We have the compact low-rise. The sample is Cruz Naligas. We have dense trees. Example is the La Mesa watershed. And according to the result, the highest daytime temperature was measured in local climate 3, or those within the compact low-rise region. Obviously, because you have a lot of built-up structures here, and then the lowest daytime temperature was identified within the local climate zone A, or the dense trees. So because mainly of the vegetation present in this type of local climate zone, which is, in this example, the La Mesa watershed. Okay, so according to our studies based on the 7 sites, we have identified at least 2 main causes of UHIs in the country. So number 1 is the loss of vegetation. So there is an inverse relationships between LST and NDVI. For example, built-up barangays have more hotspot pixels, while highly vegetated barangays have more cold spot pixels. Okay. So in this example is a PlanetScope expansion map for Baguio City. In 2012, we have a vegetated area here inside your polygon. In 2018, the vegetation was lost and was converted into built-up feature. So after this comparison, we will be analyzing the land surface temperature difference, and we can further prove that vegetation loss is a factor in increasing the temperature. So in other sites, we have results like in Baguio City, the lowest vegetation area are also the area with highest built-up extent and highest LST. Ayan. In Quezon City, consistent lower temperature values were observed in areas with green spaces such as UP Diliman and Quezon Memorial Circle. Okay. So next cause is the main cause, which is build-up expansion. So extensive urbanization and build-up expansion were observed in all 7 sites based on spatio-temporal analysis. So we also detected hotspot within UHI, and most of these hotspots are located within the highly dense built-up structures. So for example, in Mandaue, dense built-up barangays have higher average LST than vegetated ones. In Davao, the presence of buildings showed the biggest impact on LST. In Baguio, LST increases as built-up area increases. In Iloilo, built-up areas are gradually increasing, while in Quezon City, the highest daytime temperature was recorded within the compact low-rise zones. So when we talk about UHIs, it is very important to talk about mitigation strategies. So luckily in our country, there are already some mitigation measures being conducted. Also, although it is very limited to very few cities only. So in this example, you can see some mitigation strategies being practiced in our cities. Most are, or some are being initiated by the government, such as this Project Purao, roof painting in Baguio City. So they paint the roof with white paint to increase the albedo or surface albedo or reflectance of the surface. We also have a greening project in Esplanade in Iloilo, a proposed green space project in Manila City. So some strategies are being initiated by private or commercial establishments such as vertical garden, permeable pavements, and green spaces within malls and condominiums. So in Project GUHeat, we're going to share site-specific science-based recommendation during the local webinars. So in summary, in the Philippines, we have already previous information on UHI, although it is mainly restricted to Metro Manila. So in Project GUHeat, we further expand the analysis to 7 sites. So UHI were formed in different periods and rate. but UHIs in the country were driven by two common factors: vegetation loss and conversion of natural landscape to built-up structures. Lastly, national initiatives such as Project GUHeat aims to further understand UHI both in space and time, and ultimately to capacitate LGUs and for us to share our studies and the results of our analysis. Okay, so again, we love our cities. Maybe that is the main reason why you have signed up to our webinar series, right? So if you really love our cities, we should understand the city, understand the occurrence of these UHIs, and disseminate information and help mitigate its effects. So good morning and thank you for listening.